Welcome back to the channel, viewers and subscribers, and welcome back to another video. How you all doing? I trust that everyone is coping, and I trust that everyone is persevering through these difficult times. I know that not everyone has fully recovered as yet. Some people are trying to get their foot back on the ground, but nonetheless, it's going to take some time. So just be patient and just work steadily towards your full recovery. Now, in today's video, I'm going to talk to you about timber roof. I've been getting a lot of requests to do a video like this. All right. So the first thing I want to point out to you in terms of timber roof is that timber roof, in comparison to your reinforced concrete roof, is considerably more expensive. It is more expensive to put up a timber roof than it is to put up a reinforced concrete roof. All right. So there's two basic type of roof that we use in Jamaica. There is the Gable roof and there is the Eave and Valley roof. Okay. And these two roofs is not anything new. In the case of the Gable roof spans back to the ancient Greeks, the Greek Empire. They were the first one to introduce Gable roof. And it has somewhat comes into the Gothic period of architecture also. In terms of your Hip and Valley, based on my research, the Hip and Valley roof, the historical context of that is that the Hip and Valley is coming from the ancient Greeks. No, from the ancient Kemet, right? Not Greeks, ancient Kemet. So when we hear of ancient Kemet, not many people can resonate to that terminology, but ancient Kemet is otherwise known as the ancient Egyptian. Okay? And the correct name for that region is Kemet, not Egypt. Egypt is a new name that is coined by the Greeks. I will get into that in another history class. So I'm going to talk to you about that, right? Now, in terms of these two roofs, in terms of strength, it is being said that the Hip and Valley roof is a bit more stable and stronger towards hurricane force wind in if you're going to compare it to Gable roof. All right. And the reason why they are saying that the hip roof is more stable is that it has four sloping sides and it allows the hurricane force wind to flow over the roof much easier without little to no uplift. There's some amount of uplift, but it is not as great as it is in the case of a gable roof. In terms of a gable roof has two sloping sides and two open ends. And the reason why that is so susceptible towards hurricane uplift is that with both open ends, it allows the wind to deflect upwards and take the roof off. So if you look at the hurricane and how the wind behave, when the wind hit the building laterally, it deflects what? Upwards. Okay, and it tends to have a uplift. So because the two open ends of the gable roof is open, when it hits and it deflects upward, it tends to take the roof up. Because the hurricane force wind, when the wind hit the roof, right, and tends to go up, right, it creates what? A negative pressure, and it also creates what is called suction. And that helps to lift the roof off, right, because of negative and positive pressure. All right. So if you should ask me which of these two roofs are better in terms of a hurricane, and you should ask me which one, if you think you should use, I am not going to give you any direct answer to that because, in my opinion, both roofs, both gable and hip roof, is vulnerable towards hurricane force wind. Even though the gable roof might have been a little bit more safer, it is not considerably safer than a hip roof. All right? Both of them are vulnerable towards hurricane force wind. And the key to the structural integrity of these two roofs is mainly its construction. how you go about constructing the roof to meet the building codes and to withstand hurricane force wind. Before I begin the presentation of going through the design and construction of boat roofs, I think I made a slight error in my opening comments. I did mention to you that the gable roof is safer than the hip roof in terms of hurricane force wind. I want to correct that. It is the other way around. The hip roof is said to be, and based on research, is said to be more safer in a hurricane environment than a gable roof, because the hip roof, it has four sloping sides which allow the wind to flow over the shape of the roof, and as against the gable roof has two sloping sides with two open sides, and those open sides is vulnerable towards hurricane force wind. So yes, the hip roof is a little bit safer when it comes to hurricane condition. But if you are to ask me which of the roof is better and which one should I recommend, I'm simply going to tell you that both roofs are vulnerable towards hurricane force wind. So it is just the method of construction that is going to make the difference. I just want to make that clarification and correction. So I'm going to begin the presentation by looking at these two roofing systems. So on the left here is a roof framing plan for a hip roof, and on the right here is a roof framing plan for the gable roof. All right. But before I get into the presentation, I'm going to start from the wall going up to the end of the roof. All right. So this is the cross section of the roof. This is the typical eave detail. So I'm going to take you through the eave detail now to show you how to put this roof up in a much safer way. All right. So here we have a eave detail, right? And this is the wall here. We cut the wall here. And on top of the wall here, I have 250 by 150, 2 inches by 6 inches wall plate, right? And the reason you're supposed to use 2 by 6, right? What I've seen many people do, they use only 1 2 by 6 or 1 2 by 4. And if you use 1 2 by 6 or 1 2 by 4, guess what is going to happen? It is not going to be thick enough to accommodate the hurricane strap, because the hurricane strap, and I'm going to show you what a hurricane strap looks like. The hurricane strap has 2 holes at the bottom and 2 holes at the top. So when you put only 1 2 by 4 or only 1 2 by 6, only one of the holes is going to get to screwed into the wall plate, and that is not going to be safe enough. All right. And many people who just put up one wall plate, 1 2 by 6 or 1 2 by 4, guess what? They have no intention of putting in the hurricane strap, because the hurricane strap is not going to be properly fitted with only 1 2 by 4 or 1 2 by 6. So going forward, ensure that when you're putting on your wall plate, you use 2 2 by 6, or if you want to use 2 by 4, you can use 2 2 by 4. Okay? Because you have to take into consideration that the 2 by 4 is 2 inches by 4 inches wide. And you need to get a minimum thickness of 4 inches to put both screws into both holes of the hurricane strap. So that's the first mistake I want to correct. Now, here we have the J bolt, a flared bolt, and this is supposed to be cast inside of the belt beam. Now, what people I've seen do, what they do, and while I was on site, I see some of it too, they do not put in the anchor bolt here. What they do is to allow the vertical reinforcement from the walls to come up and they put the wall plate over it and then bend the vertical steel down, right? And then nail two nails and clamp it over, right? And that now they are saying that, you know, is a better replacement than using the anchor bolt with the flare end or the J bolts. I am not too certain about that because when you bend the steel over, the wall plate is still going to have some amount of play in it, right? And with the hurricane wind uplift under the eave, that wind, and based on the intensity of the wind force, it only need to have a little play. The slightest little movement that is in the roofing system, the wind is that is going to create the opportunity for the wind to devastate your roof or to damage your roof. So you want everything to be as tightly put together as possible so that there is no play for the wind to take advantage of. All right. So we use the J bolt here, and the J bolt is supposed to space 16 inches on center. That means every 6 inches you place the J bolt in the reinforced concrete belt beam, and you pour the concrete with the J bolt to give it proper anchorage. All right. Now we move to the hurricane straps, right? And I have a issue with the hurricane straps because, and I think it should be remanufactured, because I have seen hurricane straps, right, where they have four bolts hole at the top and 4 bolts hole at the bottom. The one I see that is presently used in Jamaica, they have 2 holes at the top and 2 holes at the bottom. And in my opinion, in my express opinion, that is not strong enough to withstand any hurricane force wind, especially now that we are getting more violent hurricane force wind than previously, right? Hurricane Mellissa that has just gone by, the winds reach up to 255 miles per hour. That is surpassing a category 5. The weather center now in Miami is contemplating now adding another category to our hurricanes and give it a category 6, right? Because a category 5 goes up to 185 miles per hour. This passage of Hurricane Mellissa, the wind speed was 255 miles per hour. So you see why our hurricane strap have to be strong enough to hold the rafter down, and I think it needs to be remanufactured to have. So instead of having 2 holes at the top, 2 holes at the bottom, it should be 4 holes at the top and 4 holes at the bottom, and properly screwed into the rafter and the wall plate with at minimum 2.5 inch screw, all right, or 1.5 inch wood screw, as indicated here. Mild steel twisted hurricane strap screwed with 4.5 inch wood screw. All right. So I'm going to talk to you now about rafter. All right, and how you can space your rafters, right, on your hip roof and on your gable roof. And by the way, this detail here goes for both hip and gable roof. All right. Now, I'm going to talk to you about the placement of your rafter, right, and how much you should place your rafter on center. But first, I'm going to talk to you about how to structurally frame your roof. All right, because the structural component of your roof is going to give it the stability towards hurricane force wind or other lateral force, right? Now, if you look at the roof, the hip roof on the left here, so all my main ridge and my hip rafters, I use 2 by 8. Right? Let me repeat. For my main ridge board and my hip here, so you see here we have 50 by 200, 2 inches by 8 inches WPP as hip rafter. Let me zoom up because I want you all to see this clearly. Right, so you see here, for this hip rafter, I use 2 by 8. Alright, 2 by 8 here as well, and 2 by 8 here as well. And for the my main ridge, my ridge board, I use 2 by 8 inches. Right? So what I've seen many people do is that they use 2 by 6 to frame the roof. Alright? I am not against that because you can use your 2 by 6, but if you use your 2 by 6 to frame the roof structurally, you're going to have to use 2 by 4s for your common rafter, and then you have to place your common rafter closer if you're going to use 2 by 4. If you're going to use 2 by 4 inches, 2 inches by 4 inches for your common rafter, the spacing and center according to the International Building Code is 16 inches on center. Right? And you can use your 2 by 6 to form your structural part of your roof. But the reason I am moving away from that, and I never used to do it, by the way, I always use 2 by 8, but I'm just giving you an alternative. But I'm saying going forward, right, it is best to use the 2 by 8 for your main structural component of your roof and use your 2 by 6 as your common rafter. And I'm going to tell you why from a scientific perspective. Now, whatever give any structure, right, its resistance towards lateral forces, its weight. The heavier the component, the heavier the structural member, it is the more resistive it is towards lateral forces. Okay? And that's why when we are building gravity retaining walls, we use a wide width, 3 to 4 feet, right, to give it more weight. They give it more weight to resist lateral earth pressure, right? Because the heavier the thing is, it is more resistant towards vertical, horizontal force or lateral force. All right. Take into consideration your own self, right? If you're outside, right, and you're a very slim person or a very lightweight person, it is going to be easier for the wind to blow you away. But if you're heavier, right, not say the wind won't blow you away or try to topple you, but you have a better chance of standing against the wind, against the hurricane force wind, because you are much heavier. It's the same thing with the roof. The 2 by 8, it's much heavier. When you frame the roof with 2 by 8s and 2 by 8s as your structural component and 2 by 6 as your common rafter, it gives the roof more weight, hence giving the roofing system more weight to stand up against lateral forces. And that's why I opt to use 2 by 8. Alright? Now, you're using the 2 by 8s as your main structural component for your roof. You're going to have to use 2 by 6 as your common rafter. So the 2 by 6, here it is, I have it here, treated 50 by 150, 2 inches by 6 inches common rafter placed at 2 feet on center. Okay, secure with 1.5 inch wood screws, right? To 50 by 50, 2 by 4 inches wall plates, and to 50 by 200, 50 by 200, 2 inches by 8 inches ridge board with twisted hurricane straps and angled strap at every rafter. Right? So your 2 by 8, your 2 by 6 supposed to be used as your common rafter. Right? Another component, and this goes for both hip roof and the gable roof, right? Another important thing that I want to talk to you about when it comes to roof, and I'm going to go slowly with this now. If you want your roof to stand up, what you have to do, you have to completely deck the roof or completely sheet the roof with 5/8 ply, or you can use your tongue and groove. The tongue and groove, it gives you a better finish, but it is more expensive, right? So you're going to have to sheet the entire roof with your 5/8 inches stick, not less than 5/8 inches thick. It can go up to an inch thick or 3/4 of an inch thick, but not less than 5/8 inches. So if you look at this note here, I have 5/8 inches thick, treated plywood, screw to common rafters with 1.5 inch wood screw at every 6 inches on center throughout the entire roof. Okay, so you're gonna screw the plywood all over the entire roof, and the screw is supposed to be 6 inches on center. And the reason why I've come to this perspective, I saw a roof down in Black River, right? Most of the houses in that environment, the roof was totally gone. But there was one roof which was sheet totally by the plywood. And even though the finished material and everything was blown off, the roof still stands. Because guess what? It was totally sheet with the 5/8 plywood. And that is critical. Alright? So take those two things in consideration. Always remember to frame out your roof with your 2x8, the structural component of your roof with 2x8. Use your 2x6 as common rafter. Place no more than 2 feet on center. Third, and most critical, sheet the entire roof, right, with 5/8 ply. It adds to the structural integrity of the roof. I know it's going to be more expensive, but if you want your roof to stand, this is what you have to do. And going forward, we know that timber roof is already expensive, and going forward, it is going to be even more expensive. Now, as it relates to the gable roof, the same principle apply. The same way how you sheet your hip roof, the same way you have to sheet your gable roof. And your common rafters, the same thing. So if you observe here, the hip roof, the gable roof here, for your main ridge here. So this center member here is your main ridge board. And if you observe, it is a 2 inches by 8 inches ridge board. So you have to ensure that you use your 2x8 for the structural component of your roof. But the only difference with the gable roof, and I'm going to recommend this, that for the gable roof, you use what is called a truss system. Now, a truss system, let me show what a truss system look like. So this is a truss here, right? And if any of you watching the video, if you're familiar with bridge design, we use a lot of truss bridge here. We use a lot of truss bridge. So this shape is very, very stable. A truss come with what is called the card here, the bottom card, the top card here, and the bottom card, right? And it forms a structural, a matter of fact, it is more even stronger than the hip roof if you use the truss system to hold the roof. So going forward, if you're going to do a gable roof, it's best that you use a truss system. So your truss system would have to span from one end of the wall to the other end of the wall. So this horizontal member here is a complete truss member. And you're going to place this truss member here at 2 feet on center. All right. So that is critical. And you still use your hurricane straps, right? And you still use your double 2x6 for your wall plate. So this give a truss roof. If you use this system here, you're going to end up with a stronger gable roof than what is used previously. All right, and you also have to ensure that you use what is called a angle hurricane strap, and this goes for both roofing system, right? So here, if you look at the ridge here, you see this member here. Let me zoom up. Right, this member here, right here, right? It is a angle hurricane strap screwed with 1.5 inch wood screws to secure rafter to truss, right? To the truss system. Or you can use it to secure the rafter to the ridge. So that is a new, right, insulation in terms of your roof going forward. So you put the hurricane strap from the wall plate to the end of the eave to secure the common rafter, and you're going to have to do it at the ridge to secure the common rafter to the ridge board, right? So you have two straps there. So you strap it to the ridge and it's being strapped to the eave. So that gives that gives the wind energy a little bit more work to do to take off your roof completely. All right. So as it relates to both roofing system, nothing is cast in stone. And if you do it the right way, not saying that it won't be damaged or destroyed, but at least it can stand up to the elements a little bit better. Now I'm going to talk to you about roof finishes. All right. Now I'm going to talk to you about how to secure your finished roofing material to your roof structure. All right. And I think it's a foregone conclusion now that everyone has come to the realization that you cannot use nails to secure your roofing members. You have to use screws. And the reason for that is that Jamaica, we are in a tropical region, and henceforth we get a lot of sunshine. We get a lot of radioactive heat from the sun. And what happens when you use nails? Nails are easily to get loose and to pull out because of what? Contraction and expansion. When the roof is being heated, it expands, and during the expansion it push up the nail. It tends to force up the nail each time it expands, and when it cools, that nail doesn't return to its original position. So every time it heats, the roofing material heats up, it expands and pushes against the nail. All right, and that is why it is not recommended that you use nails. And when the nail is being loosened over a period of time, when the hurricane force winds comes, it makes it much easier for the wind to take off the roof because the nail is already loosened. All right. So it is best to use screws because screws embedded in the roofing material more securely because it has a threaded edge, right? And as a result, it reduces the amount of frictional force between the nail and the member. Between the screw and the member. When you use the nail is smooth, so henceforth, the frictional resistance between the wood member and the nail is going to be what? High. So it's going to be easily to pull out based on the expansion and the contraction because there's no frictional force to hold it back. Okay, because it is smooth. With the screws, we get the opposite. Not saying that the schools won't uplift because of expansion, but it is going to be more difficult. When the roof eats up, the schools is going to tend to have a uplifting force or uplifting momentum towards pushing out of the wood. But because it is threaded, it is more difficult. And because the frictional resistance between the wood and the screws is much higher than in the case of a nail. So going forward, we should abandon nails to secure our roofing material as fasteners. Use screws, and that is said by more than one person. Okay, and that is what you need to do. The second thing I want to talk to you about is the roof finishes. Now there are several roof finishes that you can use. You can use zinc, you can use decomastic roof, right? Or you can use decoban roof tiles. But based on what I'm picking up now, it is best to use a standing seam for your roof finishes. And I'm going to tell you why. With the standing seam, right, it comes with clips, right? And the clips is placed over the member, and the member is screwed into the root structure, right? And the overlapping member overlap that clip with the screws, so the clip on the screw is not exposed to the element, is not exposed to any weathering or any wind force, right? So the big advantage in using the standing seam is that you have no exposed fasteners, right, or screws. It is overlapped beneath the clip on the screw with the adjacent member, right, and the process continue throughout the roof, and you have no exposed what screws for any weathering or for the temperature to price out over time, right? So with those clips too, there's a specification in terms of spacing. It should space no more than 16 inches on center, right? Because if you place it further, then you can have problems because you want to space it so that it can resist whatever force is coming to it, right? So the standing seam is a far better choice to use than the other roof choices. But guess what again? It all comes down to expense. The standing seam, and based on my checks, it is a little bit more expensive than those other roofing choices. All right? It is a little bit more expensive, and that is why I'm saying to you, going forward, if you're going to, still use timber roof, it is going to be a lot more expensive than it was previously. But if it is a choice of yours to use timber roof, then that is the way to go, right? So I'm going to sum this video up now. So let me go over one by one what you need to do. Number one, right? You need to use double 2x6 for your wall plates. You need to use your twisted hurricane straps at every rafter, right? You need to use 2x8s for the structural component of your roof. You need to use your 2x6 as your common rafter, space at 2 feet on center. You need to use a hurricane strap at the top of your ridge to secure the rafter to the ridge as well as to the eave, right? And you need to what? Sheet your roofing completely with your 5/8 thick treated plywood. And it's a reason why they say treat it, because if you don't treat it, you're going to be eaten by termites. Okay? And last but not least, I know it's going to be a little bit more expensive, but try to use the standing seam. The standing seam does not comes with exposed fasteners or exposed screws to the weather for water to penetrate it. Okay, so that is it for this video. If you find the video informative, let me know in the comments. If you watch the video and have left out anything that you can point out to me, I am willing to accept. But this is how I think we should go about roofing our building to withstand hurricane force wind. Yes, it's going to be considerably more expensive than your typical reinforced concrete slab roof. I have already done a video talk to you about the reinforced concrete slab roof and the drawbacks to that and what you need to do. But if you're going to use a timber roof or you're going to replace your blown off roof with timber roof, right? Or you want to put it back, it is going forward. Do it the right way is going to be a little bit more expensive, but at least it can stand up to the hurricane force wind a little bit better. Thank you. See you in the next one. All right? Good.